Good morning. Today's topic is molecular energy levels. So, a molecule possesses four types of energy. Which are they? Electronic, vibrational, then rotational, and translation. Okay. So, the molecular energy levels associated with these energies are called as molecular energy levels. So, electronic energy levels are the energy levels associated with electronic energy, then vibrational, then rotational and translational. So, first one, electronic energy level. So, now what is electronic energy level? So, it is associated with electrons present in a molecule which can occupy various molecular energy levels. Okay. So, it's associated with electrons present in a molecule. Electrons present in a molecule occupies which can occupy different energy levels. These are called as electronic energy levels. Okay. Are called as electronic energy levels, and these molecular energy levels, they may be bonding and antibonding. So, they can be bonding energy levels or anti-bonding energy levels. Okay. Now, the energy gaps between these electronic energy levels fall in UV visible region. Energy gaps between these electronic energy levels fall in UV visible region. Okay. Now, second one is vibrational energy level. Okay. Vibrational energy level. What is vibrational energy level? In this case, the atoms in a molecule can vibrate by keeping the position of center of mass constant. Okay, in such cases, the energy associated with these levels are called as vibrational energy level. Okay, atoms in a molecule vibrate by keeping the center of mass constant. Okay, by keeping center of mass constant. Okay. In such cases, the energy associated with such energy levels are called as vibrational energy level. Example, HCl molecule. In the case of HCl molecule, bond stretching is taking place. Okay. They undergo bond stretching. They vibrate by bond stretching. Okay. And the energy gaps between these vibrational energy levels fall in IR region. Okay. The energy gaps between these vibration energy levels come and falls in IR region. Next one is rotational energy levels. Third one is rotational energy level. Rotational. In this case, if a molecule rotates in space about an axis, passing through its center of mass, it possesses rotational energy, and the energy levels associated with these are called as rotational energy levels. Okay, if a molecule rotates in space, about an axis, passing through its about an axis, passing through its center of mass. Okay, passing through its center of mass. Okay, the energy level associated with this rotational energy is called as rotational energy level. And the molecule of gas or liquid possess this energy. Gas or liquids possess these types of energy. Okay, and the energy gaps between these rotational energy levels fall in microwave region. Okay, the energy gaps fall in microwave region. Okay, next, fourth one, translational energy level. From the name itself, the transition takes place. Okay, the translational energy level in this case, if the position of the center of mass changes with the time, the molecule is said to possess translational energy. Okay, so the energy levels associated with this translational energy is called as translational energy levels. If the position of the center of mass, if the position changes, translational, so position, if the position of the mass changes with time, okay, changes with time, the molecule is said to possess translational energy. Okay, molecule possess translational energy. The energy level associated with this is called as translational energy level. Okay, translation energy of a molecule is usually not quantized. Okay, they are not quantized because translation, change of position from one place to another is taking place. So they are not quantized. It becomes quantized only the molecule is present in a box of nano dimension. Okay, it gets quantized. The molecule, the translation energy of a molecule is not quantized. It becomes quantized only when the molecule is confined in a box. Is confined in a box of nano dimension. Okay. Now, the total energy. So, there are four types of energy. So, total energy, E total will be the sum of the electronic energy, then vibrational energy, rotational energy and translation energy. So, sum, E total will be E electronic plus E vibrational plus E rotational plus E translation. The sum of all the energies gives the total energy of the molecule. Okay. So, but in this case, the translation energy is negligibly small. So, E total will be approximately equal to E electronic plus E vibrational plus E rotational. Okay, because E translation is negligibly small. Okay, now see in the figure we can see it is explained clearly. So this first level, this is electron E1, this is E2. So first electronic energy level and second electronic energy level. Okay, and this electronic transition are always accompanied by vibrational. This is V0, V1, V2. So these are the vibrational energy levels. So it is accompanied by vibrational energy level and rotational. This vibrational consists of different rotational energy levels. Okay, and V2, V0, then V1 to V2, again different rotational energy level. Here also vibrational V0, V1, V2, then again these are divided into rotational. Different rotational levels are there. So electronic transitions are always accompanied by vibrational and rotational transitions, and vibrational transitions are accompanied by rotational transitions. Okay, this UV spectrum. So we know electronic transition, UV, the energy gaps are come under the range of UV region. So UV spectrum is appears to be appears as broadband. Okay, appears as a broadband UV spectrum. Okay, now the transition from E1 to E2 is taking place. So from E1 to E2 transition is taking place from E1 to E2. Then from here to different transition are taking place. Okay, different transition are taking place from one electronic energy level to another electronic energy level from E1 to E2. So transition from E1 to E2 is given. Okay, this much about molecular energy levels.